Hello, hello. Hello, hello. We're live. Hello, hello. I'm going to show you guys an excellent ceiling. Hello, hello. We're live. We're live. The cats are doing we're doing mealtime for the kitty cats. And we are going live. Okay, I'm also trying to attach there. Hello, Reese, how are you? Okay, you're gonna see the kitty cats real quick do their mealtime. We're gonna cover some astronomy, astrophysics. We're gonna do some things. We're gonna do some chatting. We're gonna say Happy New Year. We're gonna catch up. Hello. Hi, Null4961. I feel like I am trying to get this to be a little more straightened. And I'm gonna rotate it later on when I do my direct chatting. So the kitty cats can get their meal. We will say hi to everybody. We're just starting to go live. Hello, my friends. We are just starting our live. Please do like, share, and subscribe, and join us. Hello, Reese. Hello, Null. Exactly, Baji does love some love, and Baji does love some physics. Yes, indeed. It's the time to disco. No. I started a goal. Like and subscribe. Please do like and subscribe. Thank you for the emojis. Thank you for liking the live. Thank you for double tapping and liking the live. Thank you for hearting the live. Thank you for sending emojis. You always stream around this time. It's usually around this time, yes. It's usually around this time. How are you doing? Okay, so they're gonna get their meals. It's the time to disco. No. It's early. Can you answer my question? Hello, Lizard Cheeto Man. It's early for me. Hello, Null4961. Massive mug. It's my Stanley. Okay. I'm gonna read everybody's comments. Keep them coming. Hi everybody. Thank you for joining. We're doing mealtime, and then we're gonna do our hangout and chat and physics and astronomy and cosmology. Happy New Year, everybody. What are your New Year's resolutions? Put them in the chat. Dominate the chat. Dominate the chat, guys. Dominate the chat. As in the chat. Hopefully you're having a good, happy New Year. It's the time to disco. We're gonna be studying, we're gonna be discussing, we're gonna be looking at everybody's chat messages. Just gotta finish their foodie first. Did everybody leave? That's okay. I hope people join us again. Hello everybody, how are you doing? They just got their meal and we're gonna get started with our chat really soon here. I'm gonna go get my lip balm. My lips are really dry and it's really cold here in Boston. We're gonna be discussing the book as usual. has been waiting for me in the hallway. He's like, where did mommy go? The live is living. Hello, everybody. Thank you so much for joining, guys. Can we please get 10 likes? And can everybody double tap and like, share, and subscribe and do all those good things while we get started. And then we will look at all comments and all chat messages and say hi to everybody. We'll get started. Oh, I forgot my laptop. 1 second. One more second. Hi, Fuji. Hi, Baji. Hello. Hello, my friends. Hello. Are you here? Is everyone here? Are you all settled? Did you grab your popcorn, your coffee, your tea, your waters? See, here's my water. Actually gonna unplug it right now for now. Maybe I'll keep it plugged in. It's fine. Thank you for the hearts. Thank you guys so much. Indeed. Thank you for the hearts and the likes and the shares and the subscribes. Here's an earring. I'm only wearing one. I'll wear the other one with you. I did the gym today. It's like 16 degrees outside. I missed my bus. Or wait, no, I did not miss my bus when I was going. But I missed my bus when I was coming back. So, that happened, which is fine. Which is fine. And then I Ubered like 3 miles so I don't have to Uber the whole thing. Because I'm like, you know what? I'm gonna do some stuff in my neighborhood. So I get dropped off. Hello, my loves. Can you please like, share, subscribe? Is there a booger in my eye? Can you please like and share and subscribe? Happy New Year. Is there a thing there? Put Nivea lotion on my face. I'm still defrosting from the outside, guys. Do you see some redness in my face? It's the defrostation. It's the defrostation. I think tomorrow I'm gonna do weights at home. It is so cold. Can you like the live, please? Can we get 10 likes? It is so cold. My nose is still red from the outside. Can you please like the live? Can you like and share and subscribe, for God's sakes? Can you? Can you? Can you? Can you? Can you? Oh, one earring only. Here's another. Ow. Ow. Ah! It's been a while since I put earrings on. No, actually, no. It was like 2 days ago that I did that. Okay, they're done. Now I have earrings on for the live. Hello, everybody. Good afternoon, good evening, good night, good day, and good midday to everyone that is joining. We have with us the book that we've been covering for several lives now, Astrophysics for People in a Hurry by Neil deGrasse Tyson. We will continue on certain topics from this book. These are going to be mainly in physics, astronomy, astrophysics, and cosmology. If you're joining and if you're new here, you should definitely like, share, and subscribe. Especially you should subscribe so you can continue coming to these lives that we do quite often. And we can become permanent study friends and study buddies for physics and astronomy and these types of topics. We also have very healthy discussions and a lot of fun on these lives, talking about just anything and everything. So you should consider subscribing, bell iconing, all that type of stuff. Can we get 20 likes so that we can do the do? I'm going to announce the top fans in a little bit. I started a goal. I do appreciate everybody's kind comments, chat messages, likes, shares, subscribes, gifts, super chats, emojis, hearts, likes, all of that type of stuff. I really appreciate you and your support on this channel. Thank you. One of the most common questions asked on this live is where I'm from. And different people have different opinions on that. Reese is here. Hello, Reese. Null is here. Hello, Null. Hello. Lizard, can you answer my question? What was your question, darling? What was it? What was it? Hello, Adrian. Is that a cat? I hope so. There are cats here. She has a pet wolf called Dave. Hello, Dave the wolf. It's a massive hamster with a huge tail. Hello, Adrian. Hello, Robnoxious. I thought I saw a pussycat. Okay. Not seen Dora for a while. You have some beautiful hair. Hello, Eric. Hello, Reese. This is why you should have kept your car. Oh, shut up. Don't tell me what to do, Reese. Hello, Scott. Hello, Ray Appliance. Yes, your nose. My nose was red, right? It was so red. But you know what? This is actually my skincare routine, guys. If you're wondering, with the thanks to the universe and skin gods, why my skin is nearly perfect. It is because I do exercises at the gym, and then I do the hot tub, the showering, the sauna, which is very hot, and then I go outside in the cold Boston air, and all the pores that were opened up during all the hot activities have now closed. And I think that does something. Please ask a dermatologist or your therapist for further information on this topic. But this whole gym and outside in the cold without a car is actually my skincare routine, guys, along with genetics. So indeed, I will not be getting a car again because I don't like paying insurance for the car. It's gotten too high. A car is a liability. I pay tax to the Commonwealth of Massachusetts so I can ride the T and take bus and take Uber share and take orange line, red line, blue line, green line, trains, planes, and automobiles. Not really. I don't own currently an automobile because I also don't like parking the car. See, it's one thing to drive the car, but another to park it and another to pay the insurance for it. I don't mind driving a car, especially with very loud music on, but I don't like parking it and I don't like paying the insurance for it. And for these above reasons, I don't own one anymore. I sold it last year. I kind of wish I had a car this year so I could sell another one. Because I did like selling the car. Actually, I like selling large objects. So there is that. Anyways, Rudolph the Red-Nosed Reindeer had a very cold, cold day. Hello, Obnoxious. Hello, Manas. I'm from India, Rishikesh. Hello, Mr. Drew. Where the F were you? Hello, Manas. Hello, Mega Fan. Hello, Close the Eye. Hello, Mega Fan again. I can make what? Hello, Ronnie Elliott. Hello, Ricardo. Hello, Ricardo, honey. How are you doing? Are you a child? I say honey to the children that join. Hello. Oh, hello. Thank you. Mega Fan is saying you're so beautiful. I'm a girl. Oh, thank you. Oh, hi, honey. How are you doing? Talk to me about the black hole. Okay, Scott Matthews. Hey there, I was watching a video about dark matter potentially being clumps of gravitons. Any validity you think? Clumps of gravitons. Okay, sure, that could be. I know it's not Boston, says Obnoxious. Okay, what is it then? Hello, AB, and oh, as in I'm not from Boston, but I'm a transplant. Okay, well, many people are. Hello, Chris. Hello, Ray Appliance. Hello, Frank. Hello, Vernon. Where are you from is not important. Where would you like to go? I am where I would like to go. But also, do you mean like for travel? I do want to travel to South America this year and cover all the continents. So where I would like to travel is Argentina and Brazil and the Caribbeans again, although I've done it before. And I would like to go to, I don't know, Australia maybe, because I haven't been there. And I would like to go back to Antarctica, and I would like to go back to Europe, probably London again. I have a friend that lives there now, and I can crash with her and go to like Paris, take the train, you know, that type of stuff. But I live where I want to live, so. Hello, Kirk Frederick. What's a supernova? That's a dying star. Hello, Seth Critton. When's the wedding? Oh, this ring is a brand deal, darling. So there's no wedding, not yet anyways. Hello, Ariba. Hello, Kedar. Hello, Truth is 7873. Do you shampoo your eyebrows? I mean, I think shampoo does get into the eyebrows, so probably that is, yes, in that sense, yes. Steven! Hello, Sarah. Oh, thank you, Sarah. Hello, Dixie Normus. Oh gosh. Well, see what people are making me say. Hello, skin friends. Hello, Kedar. Sing, Mr. Telephone Man. Hello, Ray Appliance. I don't even know your name. Hello, Mr. Drew. Hello, Happy New Year, Steven. Hello, James Story. Hello, Kedar. Jose, thank you. Light switches, you ain't getting my cornbread. Okay. Of course, Steven. Hello, Scott Matthews. I think gravitons make good skin. Cole Porter says, I'm gonna get my food in the fridge. You should definitely go get your food. We're gonna be on for a while. And currently I have some oil in my hair, and I went swimming, and then I took a shower. I didn't have time for a shampoo. So it's wet, and also partly it has oil in it. I got one of my friends to put hair oil in my hair and give me a bit of a massage for New Year's Eve celebrations. We went out, we got dinner at PF Chang's. In fact, we got dinner and drinks at PF Chang's, utilizing certain deals. And then we went to a club, and we didn't really spend much money at the club. We just had to pay a cover charge of $25, and then we danced the rest of the night and hung out, and we didn't get any more drinks because we can't handle it. And I bought some wine, which I had at home, and then we came back to my place and we hung out and we had the wine. And see, this is how you do your New Year's Eve. And for people that are like, oh, New Year's Eve, like it's too chaotic outside, you're right, and you don't want to go out, that's totally fine too. But this year, so some years I'm like that and I don't really do anything much for New Year's Eve and I don't go out. But this year I realized it's okay for me to go out, because if there's chaos, it's me. I'm the chaos, I'm the loud one on the tee, and like the one that people have to like worry about when they are trying to go home safely at the end of the night, you know? So it's okay. I'm like, yeah, it is chaotic, but that chaos is me. At least in Boston. I'm the most chaotic thing about Boston. So I like it here. Jim is saying I don't drive either. Oh, Jim, you're my soul sister. How are you? Hello. I mean, in Boston, I don't drive. I would drive. I've driven for a long time in places like, well, actually, I've driven only in Ohio because that's where I learned how to drive, and that's where I lived for way too long. So I did drive there, and actually, I also drove in the Caribbeans on the other side of the road, sitting on the other side of the whatever. So on the opposite side of the road. So I also managed that. But did I nearly cry? Yes, I did. Thank you so much for joining, everybody. Can you please show some support by liking, sharing, subscribing, gifting, super chatting, whatever sounds good to you? And thank you so much. And can you make the hearts go up? Thank you so much. Stick it out for a minute. Are you going to talk more about science, please? Yes, Scott Matthews. Brandon is saying, I bet you do. What is that? What do you mean? Bet what? Truck or car? I mean, for me, neither, but probably a car better than a truck. I got my food. Hello, Cole. Hello, Chris. Rinse, repeat the processes. I'm baking cookies. Should I use deal dough or cookie dough? I like cookie dough a lot. Grant is saying, I want you. Okay, what happened to your eyes? What about them? Something happened to my eyes? Name every train in your eyes. Sing the song. Chopped. How was your day? Hello, Summer. Okay, let me do the top fans and then get on with it. Hello, number one is Robnoxious. Actually, I totally forgot to share the live, so let me actually give me a second. One second. You guys, keep it coming. Keep it coming. Keep the chat messages coming. I'm going to get it set up on my other device here so that I can read it better and whatnot. So we are gonna actually continue. Last time we talked about Earth as an exoplanet, remember, and we didn't really totally finish that topic from this book called Astrophysics for People in a Hurry by Neil deGrasse Tyson. So we will actually thank you so much. Did someone do a super chat? Oh my gosh, thank you. Hello, Stephen. Sky reading. Oh my gosh, Stephen. Thank you so much. Wow, there I go again, whining again. What are you whining about, Stephen, darling? How are you? How's the nephew? How's the nephew's boyfriend? How's your mother? How's the relatives? How's your home? Thank you. Thank you for doing the super chat, Stephen. What a surprise. Thank you. So, we started this topic, but we didn't finish it. So we will finish it tonight, and we will keep on discussing. And the chapter is, if you remember, it's exoplanet Earth, and so it's kind of in line with what some people have been wanting to hear about in regards to like aliens and such, and that type of line of thought. Even though I did admit that aliens are not really my favorite topic, but I will discuss them sometimes now and then. Generally, we discuss a lot of like cosmology, astrophysics, astronomy, and we covered two very important topics, of course, like the number one and number two top questions in cosmology, astronomy, which is, first of all, dark energy, dark matter. So dark energy being one, dark matter being another one. Those are two different things, and we also discussed them. So if you're new, please do watch out for our lives and subscribe so you can access these lives when we do go live. I'm also going to start doing member lives more as well.
So if you become a member, we will have more sort of, um, we will have more focused discussions on the topics that are more interesting for you or that you want to bring to the forum and such. Also, you should go and check all our previous lives where we have covered these topics and related topics as well, okay? So that's my little... Joe says, wait, what did you do in Antarctica? I worked and lived there for a while, working on my astrophysics. Oh my gosh, are things moving? 1 second, please. Let me just unplug the phone because it is not doing well with it being plugged in. Indeed, it is not. So I plugged in the phone because I didn't want the phone to die, but I think I'm going to unplug it for now. 1 second, please. It looks like there is a challenge here. Okay, it's all unplugged. Excuse me, please. Okay, sorry. So why did I go to Antarctica? It was for my project called ANITA, which stands for Antarctic Impulsive Transient Antenna. And it's a project in particle astrophysics that I worked on for my PhD. And it is based in Antarctica. It's a balloon-borne mission that is launched from close to McMurdo Station in Antarctica, which is more specifically, it is launched from NASA Long Duration Balloon Facility in Antarctica, but that is close to McMurdo Station, which is one of the biggest bases and the main US base in Antarctica. Okay, so that's where I lived and worked for a while. So that continent is done, and actually right now the only continent left for me is South America. So if you're from South America, hello, and tell me where you're from. I will take that as a sign and go there. So, you can see my mustache. Good. I hope that gives you some inspiration to grow one, my darling. So, okay, so now, let's see. Let me do the stream settings and make sure that things are working properly. Do you guys see my shopping situation? The shopping link is showing up, right? I just always have to double check. Yes, the shopping link is showing up. I see a men's essential sweatshirt thing. Okay, I just have this new feature where I'm able to show people links to like products, and so I just make sure that that is working. That's all, no pressure, but feel free to shop while watching if you so are inclined, okay? Okay. So let's see. Did I figure out my stream settings of the thingamawitch? Let me do that. Okay. Thank you for waiting. I really appreciate you. Save that. Thank you, everybody. Steven said everyone's good. Aw. How's the weather? It's really cold. All right, let me get started for a bit and we'll do the rest later. We will, if someone could share the live, that would be great too. Hello, Eric. It actually snowed on New Year's Eve here. Steven. Hi, Austin. Hello, Austin. Good to see you, Austin. All right. Number one fan right now is Steven. Thank you so much for the super chat. Number two is Rob Noxious. Number three is Null. Number four is Shibin Shiji. Number five is Mike. Number six is Reese. Hello, Reese. Thank you so much for joining. With newborn and everything, Reese, my mod and old friend, is here. Number seven is Body Swap. Number 8 is Scott Matthews. Number 9 is Joe Dirt. Number 10 is Kedar. Number 11 is Chris. Number 12 is Ray Appliance. Number 13 is Shad W8 1000. Number 14 is Mega Fan. Thank you so much. I hope you like, share, and subscribe. Number 15 is Diana. Hello, darling. Please do like, share, and subscribe, and keep coming back. Love to have you here. Number 16 is a Bat Height Ka Ray. Hello, Bat Hi. Number 17 is Austin. Hello, darling. Good to see you. I know we are usually live too late for you, but I'm glad you could make it tonight. And please go check out our previous lives. Number 18 is Adrian. Number 20 is Dance the Man. Number 21 is Manas Ravit. Number 22 is Vernon. And number 23 is Dixie. Number 24 is Destroy. Number 25 is Nusrat. Hello, darling. Please do like, share. You affect is off-putting. You affect is off-putting. What do you mean by that? Like and subscribe, please, darlings. Thank you so much. Oh, my accent is off-putting. Ah, love that. Thank you for the feedback, and thank you so much for the gift, whoever did that. Just be careful not to say too many mean things, because you might get timed out. Okay. Hello, Charlie. Charlie's sleeping with his mama. Oh, good job, Reese. Charlie's asleep. Broski sent a gift. Thank you so much. Birthday kissing. Well, you're so pretty. Nice face. Thank you. Thank you, guys. So we will keep on going because there is a demand for the topic tonight. So we will keep on going for a little bit here. And then we will come back to the comments and chat messages and say hi to everybody, okay? And we will share the live. And in the there isn't a mean thing. Oh, Steven. Steven is an oldie here, as in an old timer. The topic is Earth as an Exoplanet, and the book is Astrophysics for People in a Hurry by Neil deGrasse Tyson, which whom some people like and some people don't like, but here we go. NASA's Kepler telescope, designed and tuned to discover Earth-like planets around Sun-like stars, invoked yet another method of detection, mightily adding to the exoplanet catalog. So, as you might know, that we have been sort of on a hunt for exoplanets, sort of like Earth, around stars that are sort of like like our sun. But whether or not we find them is a different question. But indeed, that is a thing, and we kind of briefly touched upon this, where there's a couple different ways you could either rely on sort of a brightness dimming of the star to figure out that it has some kind of planet, where the planet goes in front of the star and very probably slightly reduces the brightness of that star depending on exactly which wavelength you're looking in. And this could be actually a very tricky method. And then there's also gravitational way of figuring out what kind of planets, if any, a star has, which depends on the fact that both the planet and the star actually orbit their common center of mass, and that will lead to a sort of jiggle gravitationally of the star. And so if there is a planet involved, this is the sort of gravitational way of finding such a planet, okay? And both are, as you can probably imagine, quite subtle, but this one, the gravitational one, might be kind of more reliable depending on the situation, because the brightness dimming one, the dimmy one, so there is the jiggly one and the dimmy one. If you're just trying to be simple about this. So there is the jiggly way, which is the gravitational way of finding exoplanets, and then there is the demi way, which is the brightness reduction way of finding exoplanets. And both are hard, but the jiggly way might actually be a little bit easier sometimes. Okay. Hello, everybody. Thank you so much for the gifts. I really appreciate you. I'll keep going and then I'll look at the chat again and thank everybody, okay? Thank you so much for the floating heart, Nunya. Kepler searched for stars whose total brightness drops slightly. So this is the demi way. Now, this Kepler is, of course, the Kepler telescope named after Kepler, the astronomer, who, of course, gave us the, Keplerian laws of planetary motion and things like that. A very important person in the history of astronomy. And now we have this telescope called Kepler, and they are doing this demi way of finding exoplanets, okay? So this is where the telescope is going to collect the data, and then we will try to find if the brightness of the star of interest out of the catalog of stars, of course, that we look at, would go down at all because of a planet passing across the star in our line of observation. So Kepler searched for stars whose total brightness drops slightly and at regular intervals. So the total brightness will drop slightly and also at regular intervals to say that, yes, indeed, there is something orbiting that star. Okay, so that's another nice thing to keep in mind. In these cases, Kepler's line of sight is just right to see a star get dimmer by a tiny fraction due to one of its own planets crossing directly in front of the host star. So once again, these are stars that are not our sun, but maybe they're kind of like our sun, maybe not, who knows? As in, it could be a diversity of stars. We will see about those details later on. But basically, you want to look at some stars and look at, of course, in Kepler's view, and look at if their brightness are slightly going down at regular intervals or not due to possible planet, okay? So that's how we want to discover. That's one way, detection method for exoplanets, okay? So with this method, you can't see the planet itself. So it's not like these things are easy to do at all. The planets, remember, don't obviously have their own brightness and luminosity, nothing compared to their host star generally. And so you can't really see the planet. Literally, you're indirectly measuring an exoplanet by looking at the brightness reduction of its host star. And as we saw, sometimes the invisible light wavelength, that brightness reduction can be so very subtle that it's very difficult to observe. It might be in a different wavelength that you try, such as food is falling, such as infrared, for example, things like that. So what clever illusion is this? Hello, Atex. We're talking about detection of exoplanets. Hello, Harry Hogg says, I like your mustache. Thank you. The jiggly way, yeah. The jiggly way. Okay. Right now we're talking about the demi way. Okay, so in these cases, Kepler's line of sight is just right to see a star get dimmer by a tiny fraction due to one of its own planets crossing directly in front of the host star. With this method, you cannot see the planet directly. So you can't even see any features of the star's surface. Kepler simply tracked changes in a star's total light. So literally the changes in the star's total light, and of course it has to be at a regular interval that total light is changing, okay? But added thousands of exoplanets to the catalog, including hundreds of multi-planet star systems. From these, and of course Kepler would have looked for a long time. Kepler, the telescope, not Kepler, the person, who is unfortunately not with us at this time anymore. From these data, you also learn the size of the exoplanet, its orbital period, and its orbital distance from the host star. You can also make an educated inference on the planet's mass. So those types of things. Okay, you can actually do these things, but once again, it's not totally it's not trivial at all. This makes it sound like it's easy, but it's really not. And again, it depends on the wavelength you use in order to pick up on that brightness difference and stuff like that. Okay, if you're wondering, when Earth passes in front of the sun, which is always happening for some line of sight in the galaxy, so this is also to do with the line of sight. So there is line of sight, there is brightness dimming, there is regular intervals, all that stuff. Well, if Earth was passing in front of the star, in front of the sun, for example, depending on which line of sight you look at, we block about 1/10,000th of the sun's surface. So not very much at all, thereby briefly dimming the sun's total light by 1/10,000th of its normal brightness. Fine as it goes, they'll discover that Earth exists but learn nothing about happenings on Earth's surface. So if aliens are doing, if aliens are trying to say, find us in this dimmy way, where our brightness, as in the sun's brightness, would reduce temporarily as we cross over the sun from their line of sight direction, briefly and very slightly. Indeed, very slightly, depending on, again, which wavelength they're using. They would see such a small fraction difference in the brightness that I'm not sure that they would really be convinced that Earth exists, and which might be a good thing for us, depending on how friendly these aliens are, right? So that's what's really going on here in terms of what we're talking about. So if the aliens are sort of doing the dimmy way, then they probably cannot see us. Thank you so much for the gifts, guys. Thank you. Brian is doing a floating heart. Thank you, Brian, for the floating heart. Thank you, Javier. You're an alien from Mexico. Hello, AWAC. I ain't afraid of no aliens. I spent Christmas Eve and Christmas morning with a lady who smokes all the time. No fun. But I was her house guest. Says Stephen. Hello, Stephen. Thank you, everybody, indeed, for the support. I really appreciate you. How's the temperature there? John Foster is asking, today it's 16 degrees and I was outside catching and missing buses while I do my gym. So when I came on, my nose was very red. I just want you to be safe. Hello, Austin. Smoking is not good for you, says Austin. Indeed. Hello, college level Hogwarts. Thank you for being here. Yay, college level is here. Thank you for the hearts, guys. Really appreciate it. Hello, Lemon Lime says, I like your accent. Thank you. You're going for a cigarette. This has been fairly crazy. Reese, are you smoking now? Hello, college level Hogwarts. Really appreciate you. Joe Dirt is saying, so the stars, with the stars flickering, has to do with our looking. Are you saying about the stars that flicker in the sky? So that has to do with us looking at a very distant source of light through our atmosphere. The dimming of the star that we're currently talking about is due to the planet of that star that might be going over the star from our line of sight. Okay, so when a planet of a star crosses over it, because of it orbiting the star, it will temporarily reduce the brightness of that star. And that is one way, one of the detection methods for finding exoplanets. And the same way could be employed by aliens when they look at us. And if they're trying to find exoplanets, according to them, and if they utilized this dimmy way of trying to find Earth, they would not be very, it would not be very easy. Maybe they could do it, but it would not be easy at all. Okay, because of this 1/10,000th fraction number. It's a very small amount that we affect the sun's brightness. Okay, so they'll discover that Earth exists, but learn nothing about happenings on Earth's surface. Also, this method would first of all be hard, but also they would not really see us at all. Okay, so that type of thing. Okay. Hello, Cameron. Thank you. Thank you for the gifts, guys. Radio waves and microwaves might work. Maybe our eavesdropping aliens have something like the 500-meter radio telescope in the Guizhou province of China. If they do, and if they tune to the right frequencies, they'll certainly notice Earth. Or rather, they'll notice our modern civilization as one of the most luminous sources in the sky. So it really, really, truly depends on visible or on the wavelength they're using. If they're using visible light wavelength, then they might not have much luck because of what we just discussed, where we don't affect the brightness of sun much. But if they're looking in other types of wavelengths, maybe they will see pick up on our shenanigans, basically. So consider everything we've got that generates radio waves and microwaves, not only traditional radio itself, but also broadcast television, mobile phones, microwave ovens, garage door openers, car door unlockers, commercial radar, military radar, and communications satellites. We're ablaze in long frequency waves. So one of the biggest anthropogenic noises, would be basically in radio waves. Like sometimes when scientists work to detect, say, a scientific signature using radio waves, they have to deal with this thing called anthropogenic noise because we use radio waves so much for our daily lives that actually it can be a big challenge when you're trying to discover something using also radio waves. But aliens maybe could pick up on this. So if those alien eavesdroppers turn their own version of a radio telescope in our direction, they might infer that our planet hosts technology. One complication, though, other interpretations are also possible. Great, this fell. Hello, everybody. That's very true. Reese pointed out that radio waves do travel at the speed of light. Thank gosh. Thank goodness. Radio waves are also a type of light, so they will, of course, travel at the speed of light. Hello, Hazelnut. You talked about K-pop a lot. Indeed, I remember. How could I forget? My main educator for K-pop is here in the live now. Hello, Diagram. You're a QT. Thank you. We all seek validation from others to raise the fact we return to nothing except energy. Hello, Ray Costello. Hello, JSTZ. Hello, International Scout Harvester. Hello, Reese. Hello, Manny. Hello, Everyday. Considering we've been sending radio transmissions into deep space since the 1950s. Thank you. Yes, indeed. Hello, Paul. 5056 Freak Show is saying your skin is flawless. Thank you. Hello, Jordan. Hello, AWAC. We're talking about the Earth as an exoplanet, also the discovery of other exoplanets from Earth. As in, we could get discovered as an exoplanet by aliens, or we could be discovering exoplanets that are planets orbiting other stars than the sun, which we already do. So that's what we're talking about. Hello, Cameron. Jupiter, yes. I saw social media posts about Jupiter. Thank you so much, everybody, for being here. Can we get 100 likes? Okay, so we use a lot of radio technology. A lot of our technology utilizes radio waves. So we're kind of noisy in radio. So that's actually a bit of a problem if we don't want to get discovered in that sense. But also it can be a problem, keep in mind, if we are doing experiments here on Earth that utilize radio waves, such as mine did. So I remember where you had to kind of be this doctor of, removing all the noise that is in radio, because there can be a lot when you are doing experiments in radio, okay? Because we use so much radio, and thermal noise can be in radio. So if those alien eavesdroppers turn their own version of a radio telescope in our direction, they might infer that our planet hosts technology. But they could also infer other things. Maybe they wouldn't be able to distinguish Earth's signals from those of the larger planets in our solar system, all of which are sizable sources of radio waves, especially Jupiter. So the nice thing is, and this is where we must be so thankful to Jupiter indeed, is that Jupiter, I don't know if you remember from our chat about Jupiter a while ago when we were discussing specifically planets in our own solar system, of which, of course, Jupiter is a very special one. Jupiter actually has some emission. And because of that, it could be that, again, we're kind of drowning in other radio sources. So isn't that so cool? So maybe they would not be able to so they'd have to be really careful. It's actually kind of funny to me, because as a person who has worked in experiments where you have to get rid of the radio noise from people, if somebody is trying to detect us, people, with our radio waves, and they cannot because of some other interference, that would be really funny, actually. But anyways, maybe they wouldn't be able to distinguish Earth's signals from those of the larger planets, especially Jupiter. Maybe they think we were a new kind of odd radio-intensive planet. Maybe they wouldn't be able to distinguish Earth's radio emissions from those of the sun, forcing them to conclude that the sun is a new kind of odd radio-intensive star. So basically, they might. So first of all, I would imagine that it would be easier to detect Jupiter, both with the Demi way and with the Jiggle way. And Jupiter actually radiates a lot of energy, not like obviously in a star kind of way, because it does not have a nuclear reactor in its belly. But Jupiter actually has significant thermal radiation, and I believe quite a bit in radio. So because Jupiter, without any people on it, is emitting so much radio, our radio emission might be sort of drowning in that, which might be another way in which people that are, well, aliens cannot find us, because there is interference. I mean, that's kind of cool though, right? I'm kind of happy about this. So astrophysicists right here on Earth at the University of Cambridge in England were similarly stumped back in 1967. While surveying the skies with a radio telescope for any source of strong radio waves, Anthony Hewish and his team discovered something extremely odd, an object pulsing at precise repeating intervals of slightly more than a second. So this type of confusion that we speak of is something that we have been confused by, us people here on Earth, us Earthlings. When we look out at the night sky, sometimes we see things that are quite confusing. Not everything is so clear. Just because you find a source of radio or something doesn't mean that there is aliens there, right? So, or people there. So confusion can happen in astronomy, and that's what we speak of right now. So Jocelyn Bell. So we have mentioned this person before on our lives. This is a quite a cool story, actually. Jocelyn Bell, a graduate student of Hewish's at the time, was the first to notice it. So this is Jocelyn Bell, a grad student who noticed this pulsating source of radio waves. And not just that, it was a very precise pulsing that was happening, like a very exact precision pulsing. So that was confusing, and I think they, if I remember correctly, because we spoke about this story before, they thought that was aliens. So let's see. Let's see what it really was. So soon, Bell's colleagues established that the pulses came from a great distance. The thought that the signal was technological, another culture beaming evidence of its activities across space, was irresistible. So they had basically discovered, quiz question, what do you think they discovered? Really, because we know now, but guess what? They thought that they had discovered aliens back in 1967. Pulsar! Yes. So they discovered pulsars. Isn't that so cool? This was the story of discovery of pulsars, which is, of course, connected to neutron stars, which is, of course, a stellar remnant. Okay? Hello, Divine Intelligent. Hello, Mark. Thank you for joining. Well, dinosaurs wouldn't have been... Okay, never mind. Hello, Article. Hello, Maddie. Hello, Carrie. How are you doing? Hello, Scott. Love to hear you talk so eloquent. Thank you. How do stars move when viewed from a speeding spaceship? How am I still in 2025? Am I in 2025? Oops. My phone stand here is proving extremely unreliable, I must confess. Sorry guys, here's my smile as I fix the as I fix the phone stand. Yay! I have heard of the wow signal. Hello, college. Thank you for liking, guys. By the way, can we get 100 likes? Hello, Divine. Miss you too. Honey ginger juice. What's your sign? I'm a Libra. So dark matter, dark energy, we can come back to as topics, okay? We'll finish up this topic for the moment. Thank you guys so much for all your nice comments and chats and likes and shares and subscribe. Your ASMR is so relaxing. Hello, J-Rock. It's true, this is ASMR. You can fall asleep to this if you'd like. Go ahead. Go ahead and fall asleep with our lives. Pulsar star. Yes. So, in 1967, this graduate student, Jocelyn Bell, discovered this pulsing signal. But not only that, it was a very precise pulse. The period or the regularity with which this was showing up was very precise, not changing much at all from, because you can see this signal, but the precision was like really high. So it was like, what is going on? And they thought that that might be aliens. But since then we've learned Somebody already guessed that this is pulsars. And as you might know already, pulsars are connected with neutron stars, and neutron stars are a type of stellar remnant. So, real quick, stars, when they die, depending on their mass, will either form a white dwarf, which is a type of compact object, or a neutron star, which is another type of compact object, or a black hole, which is the ultimate, most extreme compact object, of course. So neutron stars is sort of in the middle, and neutron stars are still pretty extreme. As in, a neutron star is a star dying and then collapsing into a compact object with like a 10-kilometer radius. So that's quite an extreme collapse and compactification of an entire star, that to a very massive star. So some of the more massive stars will make this type of stellar remnant when they die. And so actually people were kind of shocked when they found neutron stars. And I do believe we read this at one point from Stephen Hawking's book, that it actually gave some inspiration to the theorists who had predicted and worked on black holes, because they basically realized, well, if we can find neutron stars out in the wild in nature, then why not black holes? Maybe there is a type of gravitational collapse of these massive objects called stars that leads to a black hole, because it's ultimately all about how extreme the collapse is, how extreme of a gravitational event there is, right? Which would entail whether the star becomes a white dwarf or a neutron star or a black hole. So this discovery is very significant in astronomy. Discovering the pulsar thing, then connecting the dots with neutron star, finding neutron stars, which are like 10-kilometer radius objects coming from stars dying, and then ultimately finding black holes, right? So pay attention. It's an interesting story. And thank you so much for all the likes, shares, subscribes, and gifts and super chats and everything like that. Thank you so much. So, anyways, soon Bell's colleagues established that the pulses came from a very great distance. This was not happening nearby. The thought that the signal was technological and other culture beaming evidence of its activities across space was irresistible. As Bell recounts, we had no proof that it was an entirely natural radio emission. Here was I trying to get a PhD out of a new technique, and some silly lot of little green men had to choose my aerial and my frequency to communicate with us. So she's thinking that this is some aliens messing with her PhD, because and it's also that she happens to look in that exact direction for her thesis, right? Because really it depends on which part of the sky you're looking at and all of this, and what are the chances that you're trying to do something for your PhD and you just happen to look in the direction of some little green men, according to Jocelyn. Within a few days, however, she discovered other repeating signals coming from other places in our Milky Way galaxy. Bell and her associates, so this was the first one of many. Okay, so Bell and her associates realized they'd discovered a new class of cosmic object. So this is not little green men that they discovered or aliens that they discovered, but a new class of cosmic object yet undiscovered that they are starting to discover. And sometimes the beginning of a discovery is very confusing and totally unexpected and surprising. So this is what was happening. So a star made entirely of neutrons that pulses with radio waves for every rotation it executes. So they called it a star. It turns out it's actually a dying or a dead star, which has made a stellar remnant, really. But what they had found was really an object. I would call it an object from a dead star, from a dying star or a dead star. But that's what they had found, and it was made of neutrons. Hamish and Bell sensibly named them pulsars. So it's a pulsating object. There's a very regular period. It's a very precise period, and it's a neutron star. So Turns out intercepting radio waves isn't the only way to be snoopy. There's also cosmochemistry. The chemical analysis of planetary atmospheres has become a lively field of modern astrophysics. As you might guess, cosmochemistry depends on spectroscopy, the analysis of light by means of a spectrometer. By exploiting the tools and tactics of spectroscopists, cosmochemists can infer the presence of life on an exoplanet. This is another thing. Regardless of whether that life has sentience, intelligence, or technology. The method works because every element, every molecule, no matter where it exists in the universe, absorbs, emits, reflects, and scatters light in a unique way. This is cosmochemistry. So, this is another way. Depending on whether molecules or atoms or whatever is out there, depending on how it absorbs, emits, reflects, and scatters light, one can also figure out certain things, okay? Thank you so much for all your support, guys. Thank you. Like and subscribe. And can we get 100 likes? And as already discussed, pass that light through a spectrometer and you'll find features that can rightly be called chemical fingerprints. So basically, sometimes what we have to do is spectroscopy. We have to understand certain details that is not just light, but spectroscopy. We have to understand how light might have been absorbed, emitted, reflected. Okay, this is not working out. I'm just going to put this down like this and go like this. I'm sorry. Are we back? Sorry, the stand thing fell. Are we back? Can you see me? Can you hear me? Is it working? Thank you so much. Sorry about that. Thank you, Jeremy. I got this phone stand thing on TikTok and it doesn't really work very well. I am sorry. Oh, thank you, College Level Hogwarts, for confirming we're back. We're so back. Thank you. Hi, Robert is saying gorgeous. Wow, those eyes are golden. Are my eyes golden? Thank you. So this is not the best angle, but I think we just have to make do with this because the phone stand keeps on not working. There's a suction thing going on with it, which is supposed to keep it in place, but it doesn't work. Okay, thank you, everybody. Thank you, Jeremy. Thank you, Restim. Thank you, ABC. Thank you, Scott. I'm in Boston. The forehead is bigger at this angle. I do have a big forehead. It's where my frontal lobe is, so thank you, God, and thank you, universe. Hello, Amit. Thank you, everybody, so very much. Can we get 100 likes? Boston strong. Yes, indeed. Okay, so basically what he's suggesting now is that sometimes you might need to do spectroscopy. In fact, as a side note, remember we talked about how the DESI experiment, that is the dark energy spectroscopic instrument, right? So basically, this is a bit separate, but remember during our discussion of dark energy, in my discussion of dark energy, I mentioned a few experiments, and one is the dark energy survey, and then another one is dark energy spectroscopic instrument. So people do sometimes realize after doing, say, one round of experimentation, measurements, observations, that they have to actually go and look at spectroscopic data as well, because spectroscopy will give you additional information that just the light and the whatever you're looking in, whatever wavelength, that might not. So spectroscopy gives you this absorption, emission, scattering information, which also tells you something more. And that's what this is talking about, okay? So all this is already discussed. If you pass the light through a spectrometer, you'll find features that can rightly be called chemical fingerprints. So the features in a spectrometer actually gives the chemicals away from the sources that you're looking at. So whatever chemicals may or may not be present there. That's why this is called cosmic chemistry, right? Is that what cosmochemistry? Sorry. This is called cosmochemistry, where basically you're figuring out the chemistry of that object by putting the light from it through a spectrometer. So you're not just looking at the light, looking at brightness, looking at luminosity, but also you're doing spectrometry of it so that you can figure out where the emission absorption might be, and get the chemistry of that thing and get those chemical fingerprints. The most visible fingerprints are made by the chemicals most excited by the pressure and temperature of their environment. So the other thing is, yes, so what I'm saying is that molecules from an object can be seen in the light. If you do spectroscopy, yes, spectrometry. So it's a little bit of astronomy mixed with some chemistry, okay? So what happens is you might not know, like, oh, are these molecules and atoms part of something else, or is it like a technology or whatever? Like, you might not know the details, but you'll know if the light that you're getting, if you do the spectrometry, you will get those chemical fingerprints, but also you will get the ones that are more dominant. Okay, so that has to be kept in mind as well. Okay. Thank you, everybody. Can we get 100 likes? So, the most visible fingerprints are made by the chemicals most excited by the pressure and temperature of their environment. So, these chemicals that we're looking at also have to be, if they're excited, in an excited state, then they will show up stronger in spectroscopy, okay? So if they're especially excited by their pressure and their temperature of their environment, then we will see that show up more in our spectrometry, okay? So planetary atmospheres are rich with such features. So depending on what you're looking at, especially with planets' atmospheres, this can happen more. So if a planet is teeming with flora and fauna, its atmosphere will be rich with biomarkers, spectral evidence of life. Isn't that so cool? So the sun's spectrometry or a star's spectrometry will not reveal biomarkers, but a planet's atmosphere might reveal that, which is really interesting. Whether biogenic, produced by any or all life forms, anthropogenic, produced by the widespread species of Homo sapiens, which is us, people, or technogenic, produced only by technology, such rampant evidence will be hard to conceal. Unless they happen to be born with built-in spectroscopic sensors, our space snooping aliens would need to build a spectrometer to read our fingerprints. So if they do the hello Zoe. Hello Joey. So, above all, Earth would have to cross in front of the sun or some other source, permitting light to pass through our atmosphere and continue on to the aliens, because we don't really make our own light. Jupiter is a planet that does do some radiation, although that radiation will be nothing compared to the radiation from the sun, but at least it makes some of its own significant amount of its own, but Earth not really. So it would also have to be this light from the sun that is passing through the Earth's atmosphere and getting features because of our Earth's atmosphere's shenanigans, such as from human beings doing things, technology doing things, as well as life forms doing things. And then aliens would be like, oh my gosh, there's a thing there that's emitting in all this. Are you a doctor? Yes. All of our endeavors are an attempt to convince ourselves we have value. Hello, Ray. Hello, it's Tricky. So everybody does black body radiation, but it has to be kind of significant is the issue, right? So if you're really far away, you want it to be bright. We're not that bright, especially given that we're pretty close to the sun, and the sun is really, really bright. So we're kind of looking at the perspective of aliens trying to find Earth, or if they would chance upon Earth, and what they might find, and how hard or easy might it be. And it might be pretty hard, actually. So unless they happen to be born with built-in spectroscopic sensors, which maybe aliens are, our space snooping aliens would need to build a spectrometer to read our fingerprints. Like they would have to do spectroscopy to figure out the life form and the technology and the anthropogenic noise, all that, okay? But above all, Earth would have to cross in front of the sun or some other source, permitting light to pass through our atmosphere and continue on to the aliens. So even though this is not the Demi way, they would still need us to pass in front of the sun from their line of sight, okay? That way, the chemicals in Earth's atmosphere could interact with the light, leaving their marks for all to see, okay? Some molecules, ammonia, carbon dioxide, water, show up abundantly in the universe whether life is present or not. So there is more complications. Ammonia, carbon dioxide, water, just those are not enough to say that there is for sure but other molecules thrive in the presence of life itself. Another readily detected biomarker is Earth's sustained level of the molecule methane, 2/3 of which is produced by human-related activities such as fuel oil production, rice cultivation, sewage. So sewage has a lot of methane. That's what makes your farts smell sometimes, by the way, is methane, CH4. And the burps and farts of domestic livestock. So because you're farting way too much, you might be giving us away to aliens. And if not you, livestock might be giving us away to aliens, the farting cows and things like that, okay? Methane, ammonia. So ammonia is in farts as well, but methane would be the bigger giveaway, okay? So natural sources comprising the remaining third include decomposing vegetation in wetlands and termite effluences. So this is just sort of considering what aliens would see if they were trying to find us, and depending also on what technology they use, okay? So the biomarkers, if they're sort of have the capability for figuring out biomarkers, of course they'd have to do spectroscopy. Like basically these molecules on Earth, Because, you know, your fart is on Earth. It's not leaving the atmosphere. So if your farts are in the atmosphere and getting illuminated by the sunlight, because the alien's point of view or line of sight is aligning with us crossing over the earth, crossing over the sun, and the methane in your farts are showing up in their spectrometer, then they might know that you're here, because methane is more of a biomarker. Okay? You walked into a physics, astronomy, cosmology, astrophysics live session where we're talking about Earth when viewed by aliens by Neil deGrasse Tyson. And we're discussing, okay? So, this is just to give you some idea. Of course, farts are not the end-all be-all here on Earth. I'm just trying to make a point here about the methane situation of farts, where this methane would give you away. Ammonia, water, maybe not so much, but methane, yes, okay? So, but also keep in mind that it would have to be well, DCX is saying, I thought you were judging my farts. Well, if you fart at the same time as when aliens are looking and we're crossing the sun from their line of sight, then yes, it's a problem, DCX. Yes, I said farts. Okay, meanwhile, in places where free oxygen is scarce, methane does not always require life to form. Okay? At this very moment, astrobiologists are arguing over the exact origin of trace methane on Mars. Did anyone fart on Mars? Because trace methane is confusing us there too, okay? And the copious quantities of methane on Saturn's moon, Titan, where cows and termites we presume do not dwell. So methane, thankfully, just methane too is a little ambiguous because it could be your farts or it could be something else, such as we don't expect that there's human beings on Titan, but there's methane there. So if the aliens track our nighttime side while we orbit our host star, they might notice a surge of sodium from the widespread use of sodium vapor streetlights that switch on at dusk in urban and suburban municipalities. Most telling, however, would be all our free-floating oxygen, which constitutes a full fifth of our atmosphere. What did you just listen to? I'm too beautiful to be talking about farts. Hello, Arjun. You're not banned. You're here. If you can see your own comments, then you're probably good. Well, farts are relevant in this discussion. So oxygen is the other thing. We have lots of it in the Earth's atmosphere. More than other spots, other places, okay? So hello, Kevin. So oxygen, which after hydrogen and helium is the third most abundant element in the cosmos. So after hydrogen and helium, the most abundant element in the cosmos is chemically active and bonds readily with atoms of hydrogen, carbon, nitrogen, silicon, sulfur, iron, and so on. It even bonds with itself. Thus, for oxygen to exist in a steady state, something must be liberating it as fast as it's being consumed. Here on Earth, the liberation is traceable to life. Photosynthesis carried out by plants and many bacteria creates free oxygen in the oceans and in the atmosphere. Free oxygen, in turn, enables the existence of oxygen metabolizing life, including us and practically every other creature in the animal kingdom. So we breathe oxygen, that's a detail, but the fact that we have oxygen, which could have done other things, but we're constantly making oxygen too on this earth, right? Which, by the way, is, a magical thing. We must thank plants for that, photosynthesis for that, all the people who are involved in plants for that. It is what makes life possible here on Earth, right? Among other things, but it's important. We Earthlings already know the significance of our planet's distinctive chemical fingerprints. But distant aliens who come upon us, will have to interpret their findings and test their assumptions. Hello, Robert. I don't know what you said. Hello, Chicago. Hello, Ray Costello. Thank you, DCX. Hello, Japan. Hello, Masi. Hello, Robert. I have golden eyes. Thank you. Hello, Yesterday. Hello, Scott. Hello, Jane Smith. Thank you for the hearts. Thank you. Hello from Jersey. Oh, very nice. New Jersey? Hello, Chicago. Good evening, Stephen. Thank you. Too smart to be in Boston? What do you mean? Hello, bad guy. Boston has smart people. Hello, Unspoken. How are you, Reza? Hi, ABC. Hi, Jane Smith. Thank you, everybody, so much. Thank you for the hearts, likes, shares, comments, chats, emojis, likes and subscribes. Thank you for 100 likes. So somebody said, how can farts expose us alien if aliens live light years away and gas travel way slower? So it's not that the gas will travel. It's not like your fart will travel to the aliens. It's that your fart, when they look at Earth, if you happen to be farting, and everything is lined up so that sunlight goes through your fart, and if they did spectrometry of that sunlight, then they would see methane, and that would be a biomarker giveaway. After doing spectrometry. So it's really the light that they would see, okay? Not that the fart would reach them, but the light would reach them, okay? But they'd also have to be, it would have to be lined up so that the line of sight is lined up for the sunlight to pass through your fart, okay? Because without the spectrometry, this methane story does not hold. So free oxygen is surely biogenic. How about methane? So now we must also remember that the fart example has to do with methane, but this oxygen example is probably a better biomarker, because methane is also on other places like Titan and other planets that don't have life. So so that there is that as well. Okay. Neptune, yeah. So, must the periodic appearance of sodium be technogenic? Free oxygen is surely biogenic. How about methane? It too is chemically unstable, and yes, some of it is anthropogenic, but we have seen that methane has non living agents as well. Hello, Kenneth. Hello, Kenny. Hello, Ray Costello. They'd have to commit a lot of resources to making contact with us. Yes, of course, they'd have to do, they'd have to do either, they'd have to know that we're here, first of all, either by the Dimi way or the Jiggle way. Dimi as in reduction of brightness of the sun because we're crossing over it. Jiggle would be because of the gravitational effect of us on the sun, which is very tiny. And then they'd have to do spectrometry to figure out the molecules in our atmosphere. So they'd have to be quite dedicated, yes. And they'd have to also be looking in the right direction in the first place to figure out that there is anything interesting at all. And they might not really know that there's anything interesting enough to really look in our direction. It might have to be sort of a chance thing, okay? Your conversation is competing with your beauty and losing. Thank you. I mean, I guess. Thanks, I guess. Yes, sir is saying intelligence, amaze you, anything on planet Mercury. We have talked about Mercury in the past. We can go back to it at some point. Happy New Year. Can you guys do the Happy New Year gifts? I believe there are gifts that are specifically Happy New Year related. Thank you. Scott is saying your parents must be so proud of you being so brilliant. Oh, thank you. There it is. Oh my gosh. Thank you, Jeremy. Jeremy Dozenberry is saying New Year's Eve. Oh, thank you. New Year's Eve 2026. That's the gift. Okay, yeah. That is what I was thinking of. I wasn't sure what it was called, but I knew there were New Year's type of gifts. Thank you, Jeremy. They won't see us. Scott is saying they won't see us. See, you know, for the people who are always curious about us finding aliens, do you see how if we're so difficult for aliens to find, do you see how it would be difficult for us to find aliens? It's actually incredibly difficult. It's not... Thank you, yes, sir. It makes me happy knowing women like you are making changes in this world. Thank you. I think all the satellites and radio traffic would be like posting up a lighthouse in the total. But we're not unique with that, right? The satellites and the radio traffic seems a lot to us, but remember that Jupiter also does it and Sun also gives off radio waves. So we're not actually unique even for that. Sure, we make a lot of technological related radio waves, but so does other planets and so does the sun, and we might be drowning in that, right? So, but you're right that I think as far as wavelengths of light go, the visible wavelength might not be the way to go when trying to detect us, especially in comparison to the sun, right? The light, does it have certain colors depending on the type of chemicals or gases? It will be absorbed or there. So spectroscopy, there would be some dips and peaks depending on what chemical is absorbing part of the light in its excited state, absorbing or emitting there will be dips and peaks. Okay, it's kind of like looking at a bunch of peaks and dips in a spectrometer. You can basically see that the light, basically all of that is to say, when the sunlight goes through a certain molecule, depending on the chemistry of that molecule and it doing something to that light, where it may absorb certain part of the light or emit something which gives you certain other feature, you can know what molecule the light passed through. And of course, the light will pass through that molecule if that molecule exists, and if line of sight is such where the light is passing through where you're looking, from where you're looking, okay? Hello, Jeremy. But by the way, we can talk more about spectroscopy. It sounds like that could be a topic of interest. And because we're talking about spectroscopy right now, and it's actually very, very, very important in astronomy. So we can certainly talk about what spectroscopy is. But this today can be your little preview introduction of it. I'm single if you're looking for a husband. Oh, hello. Yes, sir. Have you drank water today? You're welcome. Hello, Paper Chaser. Hello, Mississippi. Thank you for the 100 likes. Yes, each molecule has a different signature. Each molecule's interaction with light is different, giving it a chemical signature. So that is how we know what certain stars have, what the planet would have, etc. But the nice thing about stars is that they make their own light. Planets don't really do that much, right? In comparison to stars, it's like nothing. So you have this added complication that the sunlight would have to pass through the molecules on our Earth, right? So that's the thing. This is from a book called Astrophysics for People in a Hurry that we are referencing by Neil deGrasse Tyson. Hello, Kiko. Thank you. The water. H2O. Hello, DFG. Hello, Jack Nitro Burst. Thank you so much. When you get to the red carpet, can I be your +1? Thank you. Hello to Philippines. Jerry is saying shout out watching from Philippines. Hello, Jerry. It's difficult to fathom space and time, yes. The magnitudes are... Yes, if you look at the event horizon of a black hole, we're observing what is interacting with the light around it. Yes, so black holes don't let light escape. So classically speaking, of course. And so sometimes, I mean, pretty much all the time, it's a couple of things. The gravitational effects of a black hole on objects around it give it away. And also sometimes when things fall into a black hole, they can emit a lot of radiation because of their acceleration. And that can also give away the presence of a black hole. So somebody just mentioned about that. There can be these sort of indirect ways in which we can know that something is there, okay? Which is very interesting. She got the Sora Aura knowledge. Hello, Sigma Wolf. Thank you for liking the live. This is water. Thank you for reminding me that I should drink some water. Actually, let me share the live. I don't think I did that today. We are live. Thank you, everybody. We will keep going. Hello, Simon. Hello, Carlos. In a moment, I will make a warm drink and drink that with you guys. Okay, so if the aliens decide that Earth's chemical features are sure evidence of life, maybe they'll wonder if the life is intelligent. So from the oxygen, from the methane, maybe they conclude that Earth does have life. But then they might still have a question of whether that is intelligent life or is it like not so intelligent life. Could be the dinosaurs, like some people were suggesting, right? Thank you, yes, sir. Presumably, the aliens communicate with one another, and perhaps they'll presume that other intelligent life forms communicate too. Thank you, cream cheese, for the gift. Oh my goodness. Thank you, Steven. Thank you, Simon. Thank you, Tyler. Whales, yes. Maybe they'll think it's whales. No intelligent life in South Boston. Oh my goodness. This New Jersey person is hating on us. Which is fine. We can take it here in Boston. Happy birthday, Phoenix. Okay. Maybe that's when they'll decide to eavesdrop on Earth with their radio telescopes to see what part of the electromagnetic spectrum its inhabitants have mastered if they're trying to figure out whether we're intelligent or not. So whether the aliens explore with chemistry or with radio waves, they might come to the same conclusion: a planet where there is advanced technology must be populated with intelligent life forms who may occupy themselves discovering how the universe works and how to apply its laws for personal or public gain. Looking more closely at Earth's atmospheric fingerprints, human biomarkers will also include sulfuric, carbonic, and nitric acids. Sulfuric acid is another one that is also a biomarker, and carbonic and nitric acids, and other components of smog from the burning of fossil fuels. If the curious aliens happen to be socially, culturally, and technologically more advanced than we are, then they will surely interpret these biomarkers as convincing evidence for the absence of intelligent life on Earth. So it depends. It depends on their perspective too. I believe that all the laws out there are similar to us. Ben, hello. Somebody said, so you can see the ad that's on my live. Thank you so much for confirming. Harvard and Cambridge is another story. Hello, Nasib. Hello, Dialectical. Dialectical is here. I'm trying to develop an anti-AI doomer thesis that shows that we're already in a simulation because AI would have already developed and traveled here by now. I hope to get my books in next week or so. Hello, Stephen. You've been here? Okay. Happy birthday to Phoenix. Thank you. I don't even know. There should be sort of a YouTube shopping link on the live, and YouTube can play ads to support my channel. So thank you so much for your patience. Intelligent life wouldn't make weapons to kill each other. So yes, indeed, after seeing what they see on Earth, who knows, the aliens might think that we're quite stupid, and so they might not think that we're very intelligent, depending on what they see. Hi, Jeremy. Thank you guys for the hearts and gifts and everything. So the first exoplanet, by the way, that we discovered, so this was all from the perspective of the aliens who might be seeing us, if they see us. But as far as us looking for exoplanets, we have done that, and we do have a list of exoplanets that we have discovered. The first one was discovered in 1995, and as of this writing, the tally is rising through 3,000. So we have discovered thousands of exoplanets so far, most found in a small pocket of the Milky Way around the solar system. So there is plenty more where they came from. After all, our galaxy contains more than 100 billion stars. That's a lot of stars that could potentially have planets, and if we discover those, then those would be all exoplanets. And the known universe harbors some 100 billion galaxies. So lots of galaxies with lots of stars could have planets for us to discover. But of course, there are some challenges. We have gone into that with more detail in our exoplanets live stream in the past. But with those couple of methods, the Dimi way and the Jiggly way, and also some spectroscopy, if possible, we can learn a lot. Our search for life in the universe drives the search for exoplanets. So everybody that wanted to hear about aliens, this is your topic. Pretty much, if you're interested in aliens, you might want to contribute to the discovery of exoplanets, of course. Some of which resemble Earth, not in detail, of course, but in overall properties. A lot of them actually initially that we were finding were a lot more like Jupiter and Neptune than like Earth, but later estimates extrapolating from the current catalogs suggest as many as 40 billion Earth-like planets in the Milky Way alone. So this is an estimate. Those are the planets our descendants might want to visit someday by choice, if not by necessity. So there is hope that maybe there are some Earth-like planets out there. And if we find some, then we can also estimate pretty much how many there might be in this galaxy if we figure out traveling to such far distances. But yeah, so that is the chapter from Neil deGrasse Tyson's Astrophysics for People in a Hurry called Exoplanet Earth, which kind of talks about aliens finding us as well as us finding potentially exoplanets that may host aliens. I will now keep on going. to the, let's see. What shall we talk about next? We can talk about the dimmy way and the jiggly way in some more detail. Thank you for all the comments, by the way. So actually, I'm thinking now, the next part of this live, we will talk about exoplanets in a bit more detail from my other book that I have. Hello, Wolf King. There she is, the most magnificent woman in the world. Listen to her, she's very wise indeed. Thank you so much, everybody. Thank you. Hello, Dialectical is saying, if Mars developed independent life, extrasolar intelligent life is a near certainty, which means simulation theory is a near certainty. Okay. Where is that Tesla out in space? It should have passed Saturn by now. I don't mind if I had some friends from outer space. Hello. Okay, so let me get my other book. So I haven't used this book in the last couple of lives, but it is a really nice book. And it's also a textbook. Okay, so hopefully you will find it useful. So this is a textbook. It's called Foundations of Astrophysics by Barbara Ryden, Bradley, and Peterson. It's several years old at this point, so not everything might be the latest and greatest information, but we will touch upon this topic of exoplanets now in a bit more detail, okay, from this textbook. So let's do that. But before that, I think I have to make myself a warm drink. So I'm gonna go do that in the background here while you collect yourselves to chat about exoplanets. I don't have hot cocoa. I have some Horlicks. I will make that. Everybody, thank you for the comments. What is the probability of advanced life in just the Milky Way? Hello, N. Further. Hello, Monu, Monica. Oh, good. You got outer space books. Thank you. Thank you, serving my Redeemer. Stay thirsty, my friends. Knowledge, wisdom, and understanding. Thank you, serving my Redeemer, for the super chat. Really appreciate you. Hi, Britanna. I don't know. Someone's asking what did people do before live chat? Thank you. Y00. Thank you, DFE GCD. Britanna, I give you a shout out. Okay. Thank you once again, serving my redeemer. Thanks for the $5. Really appreciate you. Okay, so we will speak about, so you will see some of the things I was talking about earlier in a bit more detail now. Remember that I mentioned about the Demi way. Those are my nicknames for the couple of different detection methods for planets, well, exoplanets. I call them the Demi way and the Jiggly way. So those are my nicknames to kind of keep it simple and explainable for detection methods of exoplanets, okay? Demi way has to do with dimming of the brightness of the host star. And jiggly way has to do with the gravitational effect of the planet on its host star, which leads to a sort of a jiggle in the in that star that we can also observe because really both things are orbiting their common center of mass. Okay, so that is what I mean, and there we go. I have this. So this is a textbook for astronomy and astrophysics majors. Once again, okay. This is Foundations of Astrophysics by Barbara Ryden and Bradley Peterson. Hello, baby booba. Hello, Johnny Doo. Hello, Curtis. What do I believe in, as in what? So, detecting exoplanets. This is going to be out of chapter 12 of this book. In fact, let me tag this book. And chapter 12 is called The Solar System in Perspective. And we can talk about exoplanets a little bit from here. And before that, let me tag the book so you know what book I'm talking about. And also, I need to make myself a warm drink. So please do. Hold on. Send you a copy. I'll tag it and then you can send yourself a copy. It's cold. It is so cold. Yes, I need to up the heat. It's cold, isn't it? It's cold, isn't it? It's cold. It's cold, isn't it? By the way, if you're joining, you can rewind to see the full live. Okay, I should have saved this book, so let me tag it. Let's see it. Where are you? Scooby-Dooby-Doo. Where are you? So this book has more math and details. Actually, let me just search for it. Foundations of... Both the authors are at Ohio State, which is well known for astronomy. Ooh, I found another book. I'm going to tag that too. This is called Introduction to Modern Astrophysics. This book is also a book that I have. Oh, I found it. Perfect. This is another book I have, which is also really useful for astrophysics. So great. I tagged both of them. So you'll see in the YouTube shopping link, you will see now this book that I am tagging, and you can get a copy for yourself if you so wish. I told YouTube to show it, so hopefully it will. It's called Foundations of Astrophysics. It's got that blue cover, and then there's also an orange book in there, which is called Modern Astrophysics. Hello, Adium Sinstri. What's your question? We won't probably go through too much math in this discussion. Hello, space-time entanglement. How are you? Yes, so I tagged two more things which are relevant. Introduction to Modern Astrophysics and Foundations of Astrophysics. So those are both books that we reference on this channel a lot. Okay? Sebastian is saying, are you a star? I do come from a star, but thank you. Okay. Okay. Now I will need to make my drink, my warm drink, my warm drink, my warm drink. Let me just... We are discussing exoplanets. Join us. I'll say that. Cosmic Baddie Live 2026 here. Okay. I'm also updating the live description. Bill Nye. Hello to Bill Nye. I have a space heater, but the downstairs is more cold than the upstairs. I think if I hold a warm drink, that will help a lot. Also, it's January. This is not a permanent problem. Lord Byron is asking something to do with sound. So sound actually needs a medium to travel. Travel period. So hello Javier. So it's not like we would hear it. Probably we would observe it with like light, particles, gravitational waves. Pretty much astronomy utilizes either light of different wavelengths, particles, and gravitational waves to pick up on signatures like supernovae, collapse of things, mergers of objects in the cosmos and things like that, okay? Carl Sagan's The Pale Blue Dot. We can certainly bring that as well on the channel. We were discussing the pale blue dot last time in that same chapter when we started it last night. Thank you for the gifts and super chats and likes and shares and subscribes. Subscribe, please. Okay, now I will be making some Horlicks, guys, and I will be back and we will discuss the exoplanets in more details. Do you guys know what Horlicks is? I'll show you. Oh. Three. Oh, I'm gonna have to cancel that. I got an email with some subscription alert. Hello, Dixon. Happy birthday. Okay. Be right back. So, let me show you. This is Horlicks. It's from the Indian grocery store near me. This is Horlicks. It has protein, calcium, and iron, and I drink this, especially in the winter. So let me see. What is this really? It's a malt, barley, wheat, flour, ingredients list. Malt, wheat flour, milk solids, sugar, wheat, gluten, minerals, edible salt, soy, protein. Okay, whatever. But that's what I'm gonna make right now and eat it. Okay, or not eat it, drink it. So give me a moment. I need to make this so I can hold a warm mug and sip it. Also, sorry, I have to use the bathroom. Good Lord, lol, Dunkin' Run. What do you mean? It's not pancake mix. It's Horlicks. How do you guys not know this? It's from my store. It's from my Indian grocery store. But I have to, oh, thank you. Space entanglement. Space time, thank you. Love those cosmic earrings you're wearing. They look great on you. Thank you. These are from India. These are pearls from India that I received as a gift. You can take care of business. I'll be right back. I have to pee. So college level Hogwarts. Hogwarts, please do keep the chat alive. Get some likes and subscribes. Get some shares. Indian pearls. Yeah, these are Indian pearls. Get some likes, shares, and subscribes. Get some gifts and things going and whatnot. And can we get 200 likes? I'll be right back.
the bathroom. Just had to make them relics now.
We can get to 200 likes. I am back. Are you guys talking about Harry Potter now? Oh my god, I love it. Harry Potter. I love Potter. I am feeling relaxed after the bathroom. Just gotta make the Horlicks now. I'm in Massachusetts, in Boston. Curtis, Edunova, hello. Potter. I love Potter so much. I just saw the play, Cursed Child, in Boston. It was only playing till December 20, but I'm also gonna catch it in New York, where Tom Felton is playing Draco. Right? So I've also seen it in London. So it'll be my third time when I see it in New York. I recently saw your videos. I do sing sometimes, but it's mostly all physics, astronomy, cosmology.
Thank you for the likes and shares and subscribes. We'll get a yellow mug. Use some milk. Maybe we can get 200 likes. That would be amazing. salt mix. I love Horlicks in the winter. I love it. I love it, I love it. Okay. Thank you. Oh my gosh. Acacio, how are you? Thank you for the super chats. Do it. Who are the top fans right now? Number 1 is Steven. Steven did a super chat. Thank you. Number 2 is Jeremy. Thank you, Jeremy. Number 3 is Scott Romer. Thank you, Scott. Number 4 is Serving My Redeemer. Number 5 is College Level Hogwarts. Yay, our mod. Number 6 is ABC. Number 7 is DFGCD. Number 8 is Austin. Yay, Austin. Number 9 is Brian. Number 10 is Ray Costello. Number 11 is Lolo. Number 12 is Joe Dirt. Number 13 is Kenny. Be back with my Horlicks. Okay, guys, I have my Horlicks in milk situated.
Thank you, sister. Oh my gosh, thank you for the gifts. All better. Yeah, all better. Even my eyebrows are a little up now. All better. Acacio! Acacio, thank you so much for the super chat. Happy New Year, Professor, says Acacio. Acacio, thank you. How are you, my friend? Hola. Hola, amigo. Muchas gracias. How are you, Acacio? Acacio is saying Happy New Year. Thank you for the super chat. Hello, Pat. Only very little Spanish, yes. Hablas un poco de español, yes. Sí. What's a terrible system? Where are you, Dialectical? What's your number? Dialectical is number 29 right now under the super chats. Or not super chats, sorry, top fans. So I think top fans, like now number 1 is Acacio. So Acacio did a super chat. Thank you so much, Acacio. So he's now number 1. Number 2 is Steven Sky because he also did a super chat. Number 3 is Jeremy because he also did a super chat. Number 4 is Scott Romer. Number 5 is Serving. So I think after that, yeah. Number 6 is a college level Hogwarts. And then I didn't read the full list. But thank you all so much for being here. How to get number 1? I think you have to do a super chat. That's more than $20. Acacio did a super chat of $20, which is the highest super chat at this moment. Happy New Year, Acacio! So you'd have to do a super chat more than that. It's based on money for the, yeah. Thank you. Hello, Curtis. Can you take me to dinner? I already had dinner. Can you do a super chat? You can pay for my gas bill. The gas bill of last month here in Boston was over $200. You could cover that. The gas bill would be highly appreciated. Highly. That's how I have heat in the winter. So last month, well, I don't know about January. The January bill is going to be higher, I'm sure. But okay, let me tell you my power bill. My power bill, so electricity, whatever, is like between 50, 60. It's like 50, 60. There might be like 1 month in the summer when it's closer to 100 for the power bill. But my gas bill is a lot of money. So I'm just telling you, last month it was 200 something. So if you do my gas bill, you'll be number one. You will be my number one in the live. And you could do it next time too. Hello, Nana. Am I from Somali? Like, am I from Somali? You tell me. The people in the live tells me where I'm from. The people in the live tell me where I'm from. Hello to Mexico. I have a glowing forehead. I am from Earth. This cup is not that big. Cash App? I have PayPal in the description, but I don't know. I'm from Norway. Norway. Salma, sister. Can we get 400 gifts so that it's a nicer number? Hello, Brian. I'm a cat mom, yes. Hello, Milwaukee. So my username on Venmo is OindryB, same username as the YouTube. I'm guessing that's probably my same username on Cash App, although I don't use Cash App much. And I also have PayPal in the description. Okay. Thank you, everybody. Keep the love coming. But you've made me a little curious. I do want to figure out my Cash App. Do I? I think I did set it up at one point. My nationality is the US. Is Cash App better than Venmo? I'm doing it right now. It's all about the same. Okay. Well, then forget it. PayPal or Venmo is better for me. Oh, God. Zell. Really? Zell? Hello, Aspen. Hello, Snowball. No take backsies, huh? We're doing astronomy at the moment. Well, currently we're discussing Venmo versus Zelle. That is my Venmo. Cash App, haven't logged into in a while. That would be cool if I got a Venmo. What do you call notification? Okay. And then for Zelle, well, Zelle, I have a number. Then I'd have to like share my phone number, right? That's probably a little bit, it's probably a little too much. A little too much. I might be starting to teach astronomy on OnlyFans and be the only astronomer on OnlyFans. If that's what this is about. Do you think there's anybody else doing astronomy on OF? Stay here, right? That's what I thought. Dialectical, you might want to behave. Thanks, everybody. All right. So, ooh, maybe I'll do a Patreon. That might be better. I know OF is about that stuff, but it doesn't have to be, right? I have an open mind. I know somebody on YouTube that does OF for tarot. If people can go to that for tarot, then why not astronomy? Can we get 200 likes? Although astronomers have developed a broad outline of how the solar system formed, details are still lacking. One of the most active fields in astronomy is the study of exoplanets. Got it. Anyways, as more exoplanets are discovered, so these are, by the way, planets that are the planets around stars other than the sun are exoplanets. As more exoplanets are discovered, the statistical study of planetary systems will allow a better general understanding of how planets form and evolve, and whether our own solar system is ordinary or anomalous. Detecting planets around other stars is far more difficult than detecting planets orbiting the sun. So, have no doubt about this, where our solar system is our home star system. Exoplanets are a lot harder. Okay, so Neptune was discovered when it was close to opposition, around 29 astronomical units from the Earth. By comparison, the Sun's nearest neighbor among the stars, Proxima Centauri, is at a distance of around 270,000 astronomical units. So over here, we have Neptune, which is not that far away, 29 astronomical units away. At that point when we discovered it. And now we're speaking of exoplanets, which are planets around other stars that are not the sun. And well, those, planets would be really far, because even the nearest star, Proxima Centauri, is still so very far away. So speaking of, like, we talked about the difficulties and challenges of finding exoplanets. This is a big one, okay? The sheer distance is really huge. Hello, Jose. Hello, Scott. Hello, Hardworking Sloth. Hello, Gar Sleazy. Hello, Dirk Kelly. Hello, Abraham. Hello, Banana. Hello, Muff Diver. Thank you, everybody, so much for all your support. Hello, Ayush. Okay, so to illustrate the difficulties involved in detecting exoplanets, let's imagine we're located at the position of Proxima Centauri, which is, of course, the nearest star other than our sun, and want to detect Jupiter as it orbits the sun. So Jupiter is the largest planet in our solar system, right? And let's say we're trying to observe it from Proxima Centauri. Never ask a queen to cut her hair. Hello, Jose, darling. Pay attention to the astronomy, okay? So, Jupiter is on a nearly circular orbit, with semi-major axis of 5.2 astronomical units. So we are 1 astronomical units from the sun. Jupiter is 5 times as far away. Okay, its maximum angular separation from the sun, as seen from a distance of 270,000 astronomical units, will be around 1.9 times 10 to the minus 5 radians. So quite small. So like being able to tell these two things apart. From a large distance, you see the sun. From a large distance, you would see Jupiter, which is quite a bit farther away from the sun than we are. But still, when you view from such a long distance away, that angular separation is still pretty tiny. So if we convert this there's some math. I might not go into it. We did go into this math in the previous live where we talked about exoplanets, by the way. In the diffraction limit case, a telescope with D of 4 centimeters would provide sufficient angular resolution to distinguish Jupiter from the sun. So pretty much it would depend on the type of telescope they have, whether they can resolve that or not, okay? At visible wavelengths, Jupiter's luminosity is due to reflected sunlight. Jupiter's distance from the sun, which is the 5.2 astronomical units or 7.8 times 10 to the 8 kilometers, its radius is around 11 times the radius of the Earth, and its albedo is 0.51. Okay, so now let me do one thing. We're speaking now of the reflected sunlight from Jupiter. So this is proportion of the incident light or radiation that is reflected by a surface, typically that of a planet or a moon. So Jupiter's albedo is this 0.51 number, okay? Now you can get a luminosity of Jupiter also from Proxima Centauri. And you also have to remember that the sun has a lot of luminosity. Albedo, let me put that in the chat. A-L-B-E-D-O, okay, albedo. So we really have to get the comparison of the sun's luminosity with Jupiter's. And by the way, currently we're talking about visible light. So let's see. The luminosity of Jupiter, ratio of that with the luminosity of the sun, our sun, of course, as viewed from Proxima Centauri, that will be, so the ratio of Jupiter's reflected luminosity. So this is albedo. This is not, what do you call it? This is not, this is not Jupiter's intrinsic radiation. This is the sunlight being reflected off of Jupiter, okay? So Jupiter's albedo, reflected luminosity to the sun's intrinsic luminosity is going to be 4. So now we've done some math, and that number is 4 times 10 to the minus 9. So basically, when you consider visible wavelength, as in visible light wavelength, the stuff that we can see with our eyeballs, that ratio for Jupiter from Proxima Centauri is 4 times 10 to the minus 9. That's quite small, right? So you have to be able to have a sensitive enough instrument that can pick up on that, right? So let's see. If an object with a luminosity of about 4 times 10 to the minus 9 of the luminosity of the sun were seen against a very dark background, it would be detectable from the distance of Proxima Centauri. So there is the sensitivity of your instrument and also the background. Like you have to be able to make that out from a large distance away. So if it's a very black or dark background, then maybe it is detectable, the object of luminosity 4 times 10 to the minus 9, that of the sun's luminosity. However, the sun's image would provide a bright background for the image of Jupiter. Making the unambiguous detection of Jupiter's image far more difficult. It's not a dark background that anybody would see these planets in. It would be the sun in the background. The sun outshines its planets, of course, by a lot, right? So one way we can increase the apparent brightness of Jupiter relative to the sun is to look for the thermal emission from Jupiter. So thermal emission of Jupiter is actually quite a bit more. So instead of thinking about that reflected light off of Jupiter from the sunlight, which is that albedo, we might want to think about the thermal emission. Let's see if the numbers get any better in that case. Thank you so much for all the likes and shares and subscribes. So, given that Jupiter's temperature of around 150 Kelvin, this implies that the wavelength of, we can basically get, it will have photon energies coming out with KT, where T is the temperature of Jupiter. And all that kind of gives you a wavelength at the end of the day, and that would be around 100 microns. So this is a 100 micron thermal emission. At these low frequencies, the emission from both Jupiter and the sun is in the Rayleigh-Jeans limit. So we will also take into account that the fact that the surface area of Jupiter is much smaller than that of the sun in order to get this new ratio. One second. Suji is drinking something. Let me just make sure. Oh, okay. It's fine. It's just water. Okay. So now we're basically kind of looking at black body radiation, because even if you consider black body radiation of Jupiter, the sun too will have that. Because remember, like, it's not like the planets, it's not like you can consider black body radiation and then not consider that from the sun. For that too, you have to consider the sun's black body radiation. Okay? So now we will approximate both the Jupiter and both the sun and Jupiter as spherical, approximately spherical black bodies, and get the ratio of their specific luminosities now for this thermal emission. Hello, Donkey. Thank you so much. So some more math later. The new number for the ratio for luminosity of Jupiter versus the sun's luminosity in thermal emission is around 3 times 10 to the negative 4. 3 times 10 to the negative 4 is significantly larger than 4 times 10 to the minus 9. So once again, 3 times 10 to the negative 4 is the new ratio. So we are significantly better off if we consider thermal emission of Jupiter from a distance away, such as from Proxima Centauri, if we're looking at Jupiter, if someone over there was trying to find Jupiter as an exoplanet. Not bad. 3 times 10 to the negative 4, much, much bigger than 10 to the negative 9. So this is the big news of today. Just by switching from visible light to something like infrared, by simply looking for thermal emission versus visible wavelength, we increase the ratio of Jupiter light to sunlight from a tiny 4 times 10 to the minus 9 to a more respectable 3 times 10 to the minus 4. Hello, Donkey. Thank you. Hello, Ennis. Hello, Abraham. Three times 10 to the minus 4 is 0.0003. Okay? So because direct imaging, so notice that this was the case with Jupiter. Jupiter is the so by the way, we picked the largest planet in our solar system for this understanding, for this particular discussion. Jupiter is the largest planet in our solar system. And also Jupiter has a significant thermal emission. We don't. For example, Earth doesn't. And remember, all these challenges we're talking about, the bright background of the sun, blah, 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 this would be much worse for Earth. And also, we're closer to the sun. That too would be worse. Like the angular separation between Earth and sun is a lot worse from Proxima Centauri, of course. So things like that, okay? But the point is that how you image something significantly affects your life and how hard it is, or how much more hard it is. But both are hard. Nothing is really that easy when it comes to exoplanets, because remember, exoplanets are planets. They're not bright sources of light like stars. And so you're not gonna have much luminosity to work with, okay? Thank you, everybody. I also need more Burt's Bees this winter. Thank you, All City. How are you? Hello, Bulai. Hello, C. Brian. Hello, Joes. Or Jose. This is a lip balm, not lipstick. You like my jacket? Well, there is some tagged in the shopping link. I found some red hoodies for you guys. Hello, Sonia. We are actually talking about aliens. This topic is extremely connected to aliens. We're talking, so you're saying to find aliens, well, you have to think about exoplanets when you talk about aliens. Where will aliens be? Probably not stars. Those are not very hospitable. So if you're wanting to understand about life form, the topic you must research is other planets, exoplanets. So you can't just ask about aliens. You have to listen to the conversation about exoplanets, okay? And that's where we are. Get specific. Aliens where? They won't live on stars. Those are burning balls of gas with nuclear reactors in their bellies. So probably not very nice for life. I mean, I could be wrong, but most likely we have to find planets around other stars, and those planets are not easy to find. We have to do this type of shenanigan in order to do that, okay? So are there aliens? I could theorize all day long, but ideally you want to measure, you want to discover, you want to experimentally find suitable planets for life form. So get specific and study exoplanets, guys, if you're interested in aliens, which I'm not even interested in aliens. I like cosmology, for God's sakes. Welcome to the live. Can you please like, share, and subscribe? Where did I get my jacket? I forget. It might be like TJ Maxx or Marshalls. Knowing me, it's probably from TJ Maxx or Marshalls because I don't really like to pay full price for things. Now I can't zip it up. Jesus. There. Mahavir, hello. The kitty cats are upstairs because it's too damn cold downstairs. And they are intelligent. So, not cosmetology. Cosmology is my favorite topic. Cosmology. For God's sakes. This jacket, it's very fuzzy and warm and soft. Inspired by this jacket that I'm wearing, I found some other red warm clothing items for you guys in my YouTube shopping link, which you can peruse. But this exact piece of clothing is probably from Marshalls or TJ Maxx from like a while ago. And these pearls are from India. Thank you so much, and can we get 200 likes? I'm so fuzzy right now, I can't even. Cosmic wave. Cosmic web. I see. I thought the earrings were alien moons. You have a beautiful face. Hello, Donkey. Thank you, Stu, Donkey. Enough of jacket. You look so pretty. Hello, thank you, Sonia. Y'all are funny. Y'all are funny. Y'all are funny. Okay, so because direct imaging of exoplanets is difficult, planet searches have so far concentrated on indirect methods of finding exoplanets. The thing that we just discussed has to do with the luminosities, whether that's invisible or in thermal emission or whatever. Thank you. So, for instance, the existence of a dim exoplanet can be deduced from its gravitational effect. So another way that I mentioned, so far, the way I mentioned, I call it the dimmy way. But now we're going to talk about the jiggly way, gravitational effect on its parent star. Newton's law of universal gravitation tells us that the force exerted by Jupiter on the sun, for instance, is equal in magnitude to the force exerted by the sun on Jupiter. Thus, instead of saying Jupiter orbits the sun, we should strictly say that both Jupiter and the sun orbit the center of mass of the Jupiter-Sun system. The location of the center of mass of a two-body system can be readily calculated. So now we're gonna talk about this gravitational effect of Jupiter on the sun. Now, of course, the sun's jiggle due to Jupiter is gonna be a lot smaller than the sun's effect on Jupiter, for example, because Jupiter is much smaller, but there will be a bit of an effect. Now, bigger the mass of the planet, the bigger its gravitational effect on the sun, on its sun. So now we will see, after skipping through some math, we're skipping quite a bit of math. Also, the method that we mentioned just now before the jiggly way is actually called direct imaging method, not the dimmy way. We will talk about the dimmy way in a bit. So, dare you not skip math? Okay, fine, we won't. So, let's use the Jupiter-Sun system as our example. If we approximate the orbit of Jupiter as a circle, its orbital speed is 13 kilometers per second. The orbital speed of the Sun will then be 13 meters per second. Thus, the Sun's orbital speed is a modest 13 meters per second, or about 29 miles per hour. With current techniques, the radial velocity of relatively bright stars can be determined to within 1 meter per second. Thus, it is technologically feasible to detect Jupiter-like exoplanets from their effect on the radial velocity of Sun-like stars. So this is that jiggle way, the radial velocity of Sun-like stars, the effect of Jupiter on the Sun and its radial velocity. Suppose that we're looking at a system that consists of a star and a single planet. So now some more math of that jiggle happens, etc., etc. And let me tell you, there is a bit of a caveat in this jiggle method. There is a problem. For example, if you get into this math, there is actually a term, sine I, where you can, the equations will give you that. It will not give you, I believe it will not give you the I, but let me read. If an exoplanet is to be detected by the radial velocity method, which is this jiggle method, it must produce VA sine I large enough to measure, where I is inclination, and there is a approximation happening here as well. Okay, we will keep going. So anyways, this VA Sinai is going to be something that affect things, and it has to be large enough to measure. Thus, exoplanets whose orbits are more nearly edge on are more readily detectable, because there the Sinai is close to 1, because sine of something, this is trigonometry, sine of an angle. In addition, since VA, the velocity, is proportional to MBMA minus 2/3 p to the minus 1/3. We didn't just define all the A's and B's here, but there's masses of the planet and the star, all that involved. The radial velocity method favors the detection of massive short period planets around relatively low mass stars. So this method is a little bit biased. It turns out how come you don't have, it turns out that this method is going to favor planets that are pretty massive, big, like Jupiter, for example, short period, and also around relatively low mass stars, like the difference between the mass of the planet and the star would be less. Okay. In addition, measuring P period accurately requires observing the star for a time P or longer. So you also have to observe the period of that planet, right? And if that's a really long time, then you're waiting that whole time. This adds to the difficulty of detecting long period exoplanets. So these issues are part of why we detected what we call sometimes hot Jupiters and hot Neptunes. By the way, you can see how hidden in the details of this detection method are basically, oh, thank you, Trollbot. Don't use this as, these difficulties are part of why we might be biased towards detecting the massive planets that are short period and also that are around lower mass stars. So anyways, I get my... Thank you so much, Trollbot, for the super chat. Study hard and don't use us as guinea pigs. Why not? That was the jiggle method. I'm going a bit more quickly through the equations. Okay, now I will in short tell you about the transit method, which is the Dimi method. I love it. Bye, Coffee Baji. You are up late. Yes, we're talking about aliens. Yes. Yes to all the above. You should definitely subscribe, guys. You definitely should. Thank you, David. Hello, David. David Hansen, 4435, has done a Happy New Year's Eve gift. Thank you so much. Thank you for the super chat, Trollbot. Thank you for the gift, David Hansen. Donkey! Donkey has done a super chat. Think out of the box and not just repeat what other people have said, because even smart people can be wrong. This is true. Donkey has done a super chat. I'm not married. What do you mean? Not anymore. Hello, All City. Oh, let's do the top fans right now. Whoops. I almost killed the live. Can you speak a different language? Yes. 3 or 4. The top fans at the moment, number 1 is Acacio because he did the highest super chat. Thank you, Acacio. Number 2, Trollbot. Thank you, Trollbot. Number 3, Steven. Thank you, Steven. Number 4, Scott. Number 5, Jeremy. Number 6, Donkey. Number 7, Serving My Redeemer. Number 8, Ray Costello. Number 9, David. Number 10, ABC. Thank you, guys. Hello, Tom. Your peace is priceless, love. Hello, Gloria. Thank you, Joshua. Joshua, did you become a member? You should become a member. Who wants a date? Okay. Ice cream? It's so cold now. Can you send the coffee money to my super chat or to my Venmo or PayPal? PayPal is in the description. Venmo is in the chat. Let me change it. And I was telling earlier that you should just I already did the grocery shopping for this month. What I need is gas bill money. Cut my hair? Oh, Jesus Christ. Thank you, donkey guy. My last month's gas bill was over $200. Feel free to send that. Feel empowered. Don't cut my hair. I will get my hair trimmed at the hair salon, but I don't think I'm going to cut it here as a stunt. Indeed, I don't think so. Boston. Only a few strands of my hair? You want me to cut my hair? Don't say that. It's cold here, guys. It's cold. Come on, guys, chip in. It's only $50. What's $50? My hair or the gas bill? The gas bill is $200. Oh my gosh! Jeremy! Thank you, Jeremy. I have a hat. Or no cat ears. Jeremy Dussenberry has sent cat ears. Thank you, Jeremy. I testify that there is no... Okay. Hello, Leonardo. Hello, C-Brand. So now the top fans, I bet, has changed. Let me do. Ooh, now number 1 is Acacio. Because of doing the super chat. Number 2 is Jeremy. Thank you, Jeremy. Thank you, Acacio. Number 3 is Trollbot. Thank you, Troll. Number 4 is Steven. Number 5 is Scott. Number 6 is Donkey. Thank you all so much. You're not number 1 yet. There's time. You could be. Number 1 is Acacio. Number 2 is Jeremy. All right. The detection of exoplanets by the transit method requires a different set of observations. So the one that I first mentioned about the luminosity. Oh my God, Scott! Scott! Oh, Scott has done it. Scott Romer has done $49.99 as a super chat. Oh my gosh. Scott! Thank you. Thank you, Scott, very, very much indeed. Oh, Scott Romer. I hope you make a lot more money at your job so that you can keep doing these super chats going forward as well, because now I'm spoiled. Now I'm spoiled, guys. Now I'm spoiled. Now I'm a passenger princess. Now I'm a passenger princess. Now I'm a now I'm a passenger. Now I'm a physics princess. I'm a physics princess now. Next live, I'll call myself Physics Princess Live. Join us now. This one I called me Cosmic Baddie. Scott, thank you so much. Really appreciate you. Thank you. Thank you, Noel. Noel is saying, Queen, you leveled up. Thank you. Hello, it's Tricky. What are you making eyes for, Tricky? What do you want? You are... Thank you, Space-Time Entanglement. Space-Time is saying, Audrey, you're the coolest. If I was Elon or Bezos, I would send you $1 million. But on one condition, I'd see what you do with that leveling up of your finances. I can have a finance talk with you guys soon. I would invest it so that my money can make more money. I'm not gonna waste your money. Definitely not. Mm-mm. Okay. Well, thank you so much. Okay, so right now, let me read the top fans again. Now the number one top fan is Scott Romer. Thank you so much, Scott, because Scott has done the biggest super chat. So that's how this ranking works, apparently. Scott has done the biggest super chat, so thank you so much, Scott, for all your support of this channel. Number one is Scott. Number two is Acacio. Thank you, Acacio, my old friend who comes to the lives and supports often. Thank you so much. Number three is Jeremy. Thank you, Jeremy, for the gifts. Number four is Trollbot, who I think I'm seeing here for the first time. Number five is Donkey. Welcome, Donkey. Hopefully you have subscribed. Please do. Number six is Steven, my old friend and first member of this channel. And a budding author. Number seven is Serving My Redeemer. Number eight is ABC. Number nine is Ray Costello. Hello, Ray. Number 10 is David. So thank you so much, guys, everybody. And please, can we get 200 likes? Yay! Someone said that if you were Elon or Jeff Bezos, you would send me $1 million, but you want to know what I would do with the money? I would invest it so I can pay my bills with dividends. That's what I would do in a nutshell. The detection of exoplanets by the transit method. This transit method is where the planet is going in front of the star, its home star, from the line of sight of looking at of the observer, because you'd also have to like see this transit happen. That is called the transit method, but then sometimes I call it the dimmy method, because it's basically this dimming of the brightness of that home star that we are measuring. Because in these different methods, we're measuring different things. That first method was direct imaging. This is where you would hope to catch some of the luminosity coming off of the planet. But if that luminosity is much, much lower in comparison to its home star, then it's kind of hard to really directly measure it. But we saw that in the case of, say, a Jupiter viewing from Proxima Centauri, you can actually improve that ratio of the luminosity much, much more like if you uh, measure in thermal, measure its thermal emission instead of visible wavelength. Then we talked about sort of this jiggle method, which is an indirect measurement, but it's basically the planet's effect on its home star and this radial velocity increase of the home star, which would be happening because of the planet's tug on its home star. The next method that we're going to talk about is the transit method. By the way, this book that we're covering all these materials from is called Foundations of Astrophysics by Barbara Ryden and Bradley M. Peterson, who are both professors at the Ohio State University, which is also where I went to grad school. And this book is also tagged as a product under my YouTube shopping link, which is hopefully visible. I think I have some hoodies on there from YouTube, but also this book is tagged if you want to get this book yourself. I should mention that exoplanets is not my area of expertise. I am learning it with you guys here from the book. My expertise is not so much the planets, so this is kind of new to me as well. I mean, I've covered this before, but this is kind of like a review for me as well as with you guys. My expertise is actually particle astrophysics. So when we talk about particle astrophysics and when we talk about particle physics, astrophysics, cosmology, those topics are more sort of what I specialized in. Whereas this topic of exoplanets, planets, aliens, you know, because people request aliens a lot, I wanted to give you the perspective, well, that aliens would mean that you have to research and find exoplanets. So we're covering this, but this is definitely not my expertise. These methods are quite specific, and even though they make sense to me as an educated person, or, you know, educated in astronomy person, but still the details of these are not my specialty. But you are in good company because we are covering it from a textbook for astronomers, which is this textbook, which I also tagged, okay? This one. We also covered, speaking of Neil deGrasse, Joshua, and others, we also covered the topic of exoplanet from Neil deGrasse Tyson's book, Astrophysics for People in a Hurry, which I also tagged in my YouTube shopping links if you want to find that and get that for yourself. It's a popular science book, and it does not have all this like math and equations, so it's not as detailed, but we did cover the topic from there as well, and it was good. Like, we had fun. Yay! Okay, so we'll keep going for at least a little bit, and then what we'll do is we'll finish up with a summary. So, okay. In the language of astronomers, a transit is the passage of a planet between its parent star and the observer. Within the solar system, for instance, observers on Earth can occasionally see transits of Mercury and Venus across the sun. So we are Earth, as in we are on Earth, and the planets closer to the sun than us are, of course, Mercury and Venus. And sometimes we can see their transits, okay? So similar to that, now imagine attempting to see the transit of an exoplanet, which is a planet in a completely different star system. We would have to see its transit in front of its home star, okay? So, and hopefully basically pick up on the dimming of that star's brightness due to this transit. So that's why sometimes I call this the Dimi method. Hello, Gerald Lake. Hello, Sergey. Welcome. Welcome to the live. Please do like, share, and subscribe. Can we get 200 likes? Sergey is saying, I'm not as smart as you, but I can build a house from the ground up. Well, that is very impressive, Sergey. I need a plumber. Can you do plumbing? I have a plumbing project that I need help with. Okay, yes, I have seen things through telescopes. Our sun is a star, yes. Most definitely. So during such a transit, the inferior planet appears as a small, dark circle against the brightness of the sun. When an exoplanet makes a transit, neither the star nor the exoplanet can be resolved in angle as seen from the Earth. However, the transiting planet can be detected. So I hope you understand. We saw how far Proxima Centauri was, and that is our closest star. It was 270,000 astronomical units away. So it's not like we will see the transiting planet of another star. But we can maybe measure the reduction in brightness of the star, okay? Because of its transit, because of the transit of the planet in front of it. So, when an exoplanet makes a transit, neither the star nor the exoplanet can be resolved in angle as seen from the Earth. However, the transiting planet can be detected indirectly since it blocks part of the star's flux. If the cross-section of the planet is pi r b squared and the cross-section of the star is pi r a squared, so some a's and b's again, then when the planet lies directly between the star and an observer, so the planet is transiting in front of its star, the star's measured flux F drops by a fractional amount. So it's this flux of that star dropping that we are trying to measure, which is why I call this method the Dimi method. And the other method, the jiggly method, because that one has to do with the gravitational effect of that planet on its star, jiggling the star. This one has to do with dimming the brightness of its star. So I call it the Dimi method, nicknames, because it's a slight dimming of the brightness of that home star, okay? So for example, once again, Jupiter. Think Jupiter transiting across the sun if we could see it as a distant observer. The sun's flux would drop by a fraction of literally 0.01%, or sorry, 0.01 or 1%. So Jupiter covers about 1% of the sun's area. So sun's flux would go down by that same percentage. The light curve of a star during a transit is something that we can look at as well. It's shown here. I can show you. From that light curve, so there's a light curve, things going up and down, we can measure the drop in flux at mid-transit. And we can also measure the times of first, second, third, and fourth contact. If we wait patiently, we can also measure. So let's say you don't want to wait for the whole orbiting to be done. This is kind of like where you don't have to wait for the entire orbital period time to see this transit happen, right? So it's a little, in that sense, it's better. And it's complementary method, okay? So we'll keep going. This time, the radius of Jupiter is 11 times our radius. This time, somebody Google our radius. I'm drinking malt. It's called Horlicks. So this time, remember how there was a Sinai term in the previous exercise? We did not go into the details of it. Thank you, Ariana, darling. Thank you, Ariana. But if you spam, then I cannot see the other people's comments. Hello, Obnoxious. We can only talk about Jupiter. Let me finish this topic though, since I already started. Do you like Jupiter a lot? We can talk about Jupiter all day long. Thank you, Scott. I wanted someone to look up the radius of the Earth. Okay. So, now instead of Sinai, there is a cosi involved. So unless the planet is only a few stellar radii away from its parent star, cosi must be small for a transit to be observed, and thus I must be very close to 90 degrees. A distant observer would see Mercury transit the sun only if Mercury's orbit were at an inclination of I greater than 89.3 degrees. Yes, it's generally physics, astronomy, cosmology, astrophysics. So, the range of inclinations for which an exoplanet produces a transit is largest for planets close to their parent star. So once again, we're kind of biased towards the planets that are kind of close to their parent star, which is sort of a bummer with this stuff, okay? Thus, exoplanets that are large in radius compared to their parent star are more readily detectable. So now that makes sense, right? If the exoplanet is really large in radius comparatively, then of course it will block more of the home star when it's transiting. So of course that will be better. And also, yes, I'm cold. And also we want it to be kind of closer to the parent star, just because of this just because of this mathematics. Okay, it's just our bias at at the time of writing this book, anyways. Hello, everybody. Thank you so much for joining. Can you please like the live so we can have 200 likes? Thank you, Jose. Thank you, Sandesh. Thank you, Abraham. Hello, Big Dog. Hello, Sandesh. Hello, Gary. Hello, Leanne. We're back. Okay, so for a dedicated exoplanet hunter, the jackpot comes when a transiting exoplanet produces measurable radial velocity variations in the star that it orbits, because you can affect some radial velocity changes, but if it's not measurable, then we won't notice, right? We won't know that it happened. And the combination of transit data and radial velocity data provides a large payout of planetary parameters. The transit allows the radius of the planet to be known. Okay, so because, you know, the other way wouldn't really say that, probably. Thank you once again, Scott. Now, let's skip over hello, Intru. Thank you so much. Please do like the live. So now we will talk about properties of exoplanets to finish off this chapter. Okay? Thank you, Leanne. Thank you, Leanne, for the gift. Thank you, Intru4969. Hello, Sandesh. Hello, Leanne. Hello, Mubina. Hello, Slip. Hello, Gary Guy. Thank you. I was about to say what? Hello, Selectrovert. Can you like the live? Can we get 200 likes? I like that comment. You have a face for radio and a voice for books. I love it. Deadly combination, right? When you have a face, a voice, all of the things. Can we see your telescope? Which Friends Day? Samson is a hobbit. Is that what? Samson is a hobbit? Okay. Whether something is a compliment is decided by me, don't you think? I think a funny comment can be enjoyed. Thank you. What is your Cash App? Can you do PayPal? It's in my description on YouTube. Because I wasn't able to log into my Cash App. Sorry. Or my Venmo would work too. Venmo username is the same as my YouTube username. Oindri B. Thank you, Gary. He's jumping up and down right now. Yay. I do stream often. You should come back to the lives. What's your question, Jaren? I do like the color red. Antarctica! Oh my goodness. Greetings. How's it going there, Dahabs? And how come your internet is working so well? It's okay. I don't mind the hate comments. The mods might mind though. Just be careful. I think while the mods are awake, you could get timed out. You look like a stranger. Hello, Nathan. Thank you. Thank you, Selectrovert. So, we will now finish up with the properties of exoplanets. That is going to be a nice discussion because it's gonna be a nice little summary of what we discussed, okay? Without too much complication. Can you please like, share, and subscribe? And can we get 200 likes? It's true, I don't have a neck. That's very true. All right, you ready, Scott and company? Yay, we're almost at 200 likes. Okay. Recent searches for exoplanets have contributed greatly to our knowledge of planetary properties. First and most fundamental, these searches have shown that exoplanets exist. It's not just an idea, we know that they exist. And that the sun is not unique in having an entourage of planets. By the middle of the year 2008, about 300 exoplanets have been discovered. So now even more. Primarily by the radial velocity and transit methods. So both the jiggly way as well as the dimmy way. With such large numbers of planets known, it becomes useful to do statistical analysis of planetary properties. When doing the statistics, however, we must keep in mind the selection biases involved in search of exoplanets. The radial velocity method favors the discovery of high mass planets because remember, higher mass planets will cause more jiggle on their home stars. So we do have a bias on that. The transit method favors the discovery of large radius planets on small orbits because large radius planets on small orbits will cause more dimminess of their home star. So we do have a bias with that as well. In general, big things are easier to detect than small things. It's easier to detect a hippopotamus in your living room than it is to detect an ant. Same reason why we can see our biases with the exoplanets. Despite the ease of detection, it is still surprising, however, to find a hippo lounging on your sofa. So even though it's easier to see the hippopotamus, or it's easier to see those bigger exoplanets, it's still kind of surprising to see those bigger exoplanets. We live on a planet called Earth, and even though there's bias here causing us to find more of the bigger planets, still it's not entirely unexciting when we find them. It's kind of like, would we expect a hippopotamus in our living room or an ant? Probably an ant, but we are finding hippos. So in that same sort of analogy, that's the case with the exoplanet search as well. One of the most startling results of exoplanet searches is the astronomical equivalent of finding a living room hippo. Searches have revealed a significant population of hot Jupiters, where a hot Jupiter is a planet with a mass comparable to that of Jupiter, but on an orbit which is less than 0.1 astronomical units. So think about that. It's a Jupiter, it's an exoplanet that is like the mass of our Jupiter, but it is so much closer to its home star. Our Jupiter is at 5.2 astronomical units from the sun. We are finding Jupiter's, hot Jupiter, exoplanets here that are within zero point 0.1 astronomical units close to their home star. We are at 1 astronomical units away from our sun. So these hot Jupiters that they found as exoplanets are within 0.1. So much more close to their home stars than even we are to the sun. Going out to larger radii, around 6% of the stars have planets in the same mass range on orbits with less than 5 astronomical units comparable to the size of Jupiter's orbit. Thank you, All City. The book is called Foundations of Astrophysics by Barbara Ryden and Bradley M. Peterson, and it's tagged in my YouTube shopping links that should be showing up on the live. Like if you click, there are multiple products. There are some hoodies. There's this book, another book. We've covered 2 books on just this live. And we cover books a lot on these lives. Hello, Tony. You can definitely go to sleep with the live on. Hello, doppelganger. My shelf? These are cat climbing trees. Eventually, yes. Eventually the hot Jupiters might basically merge with their stars. Thank you. Hi, Nick. Hello, Gum Daily. Nick Gers. So yeah. So I am getting a little tired. Oh shoot. I totally did that wrong, didn't I? Don't say Nick again. I only realized what that was when you said that. Yay. Nick, just Nick would have been enough. Because the person was like, shout out this person. Oh God. It's already disappeared. Ugh. I think I'm too tired now.
Hi, Kenneth. Actually, thank you. Thank you, Decker. I'm trying to make people happy. Well, I wasn't reading all the messages. I just decided I'll give them a shout out, and then I didn't even realize what I said. Nick. Ugh, whatever. It's fine. It's fine.